Basically that prevents the two flows of blood from coming in direct contact, and it shunts them into the right atrium, which you can see here is a very flimsy kind of structure. And if you open up that right atrium, you can see all the pectinate muscles on the inside of it. So they're kind of like a honeycomb network of muscles that prevent it from basically being suctioned in, or prevents turbulence in the blood that comes into it. So then from there we kind of made a cut down and opened up the right ventricle. And the first thing you see is all these really obvious chordae tendineae, which hold the tricuspid valves in place, or the parts of it. So there's a little piece of valve there you can see under my jigger here, my probe. And then the big structure holding the chordae tendineae in place is the papillary muscle. And it's pretty big and pronounced even in this tiny heart. It's not as big as it was in the cow. And there's some smaller structures in here that we probably won't be able to see on the video. But basically there's structures that hold the ventricle to the septum, the septo marginalis tuberculae. So they go from the side of the ventricle, the muscle of the ventricle, to the septum, and stop the ventricle from inflating too much. And there's also the tuberculae carnae, which are just basically on one surface. So I found one earlier, but I don't know if it'll necessarily show up on the video. Right there. Yep. So it just connects on the one side. So we follow this up, and we've already made the cut, but we follow up from the right ventricle, and that goes into the pulmonary trunk, which will kind of slop open here. And then you have your pulmonary valve, which I just learned is 3 semilunar things. So you can see one here behind my probe. There's a second one down in here.
And leading into the pulmonary trunk is the conus arteriosus.
The conus arteriosus,
Which is not a distinct structure.
You can't really see it now that it's been cut open, and